Hello my dear students, this is Akash SD and welcome to the SD Physics classes. Hope so you all are doing really great. So student, in this video we are going to learn about a spherical capacitor. How many cases? 3 cases we are going to see one by one. Okay students, so let's go through the first case. Okay, so here you can see the first case is what? The capacitance of an isolated sphere. First case, isolated sphere. After that, concentric spheres will come with some grounding cases and all that. Okay, so let's see here please. Here we have the sphere, conducting one. Nothing is mentioned, that means conducting one. And conducting sphere can be solid also, can be hollow also, no problem, because charge will be where? The charge will be on the surface. Okay, so let's go through it. Let a conducting sphere in air is having charge Q and a radius R. Then its electric potential is given by. Okay, so according to the situation, no, conducting sphere is there in air. Okay, air medium. So here how much charge is there? It is having charge Q. Okay, after that it is having radius how much? R. Okay, radius R. So student, the potential means by default potential where? Potential on the surface. Okay, so its potential V is given by, as it is having the air around it, so 1 by 4 pi epsilon naught, dielectric constant of the air is 1. Okay, so 4 pi epsilon naught into Q by R. Now this is the potential at the surface. Okay, now let's see capacitance of the sphere in air. As I have told you, it is given by, what is the formula here? Students, capacitance C equal to Q by V, that means charge and potential of the surface V. Okay, so here even if you will see from equation 1 also, no, so we can write here students here Q by V from equation 1. So if you will see here from equation 1, this Q by V will be how much here? You can see very well. What is this? 4 pi epsilon naught into R. Okay, so here also I can write here 4 pi epsilon naught into R. This is the capacitance of an isolated sphere. Okay, great. Now students, we have to see some important points. Now, so see here important points. First one, capacitance C does not depend on the charge and potential of the sphere. In last class also I have told you. And see, it also does not depend on the nature of material and thickness of sphere. Now, this is the conceptual kind of questions can exam have to remember this. Okay. Second one, let's see. Capacitance C depends on the shape and size. What is there? Shape and size of the sphere. That means its radius. Okay. You can see when in the capacitance term what is coming? Capital R is coming. And if in case this sphere is placed in some medium, then it will be depending upon the medium also. That we will see next one. Okay, so it depends upon what? A radius. That means shape and size of the sphere. Third one, see, if a sphere is placed inside a medium of a dielectric constant K, then its capacitance is given by. Okay, so what will happen here, students? Here, which kind of medium is there? Air is there. Okay, so for air means I will take here C naught. For air means, okay, C naught I have taken. So here for the medium I will write here C. Okay, this will be what you see? 4 pi. Air means what I told, K equal to 1. Okay, but if some medium is there, we will write here K epsilon naught into R. Now, instead of epsilon naught, what will write here? We will write here the K epsilon naught. Now, this is K actually. Now, so students, from here we can write here C. K will come outside, so here we can write here 4 pi epsilon naught into R. And what is 4 pi epsilon naught R? That is C naught. That means when the sphere were in a air, that means we can write here this C equal to K C naught here also. Just like a parallel plate capacitor, here also we can write how much? C equal to K C naught here. Okay, where? When the sphere is placed in some medium. Okay, great. Next one, let's see. Here. See. Fourth one, theoretically, if Earth is considered as a spherical capacitor, okay, then its capacitance is given by 711 microfarad. Okay, you have to remember this. And mathematically, if I talk about here, let's take C naught equal to, what is the formula? 4 pi epsilon naught into R. Now, around the Earth, we will consider air is there. So, we know 1 by 4 pi epsilon naught is what? 9 into 10 to the power 9. But here what is there? 4 pi epsilon naught. That means what will be this? 1 by 9 into 10 to the power 9. Radius of the earth how much is? 6400 kilometer. But if we write here in terms of meter, so 6.4 into 10 to the power 6. So this is the radius of the sphere. Okay. When you will simplify this, it will come 711 microfarad. Okay. Just you have to simplify this, and you know very well 1 microfarad how much here? 1 microfarad means students 10 to the power minus, yes, 6 farad. Okay. Great. Now let's see. Fifth one. Practically, this was the theoretically, but now here what is practically? Practically, capacitance of earth is infinite because its potential is how much? 0. We have learned the concept of earthing and all that. Okay. So if we talk about here the practical situation here, so Q by V, and what we can write here, see, this is Q by 0. That means practically it should be how much here? Infinite. By default, if nothing is mentioned, we will write here the theoretically how much here? 711 microfarad. Okay, students, so here we have done for which one? We have seen the case 1 when only one isolated sphere was there. Okay, now after that we are going to see the case 2. Now some concentric sphere. See here, case 2 is there. See here, capacitance of a concentric sphere when outer surface is earthed. What is there? Outer surface is earthed. So here what is there? Is this one here. See, outer surface is earthed is there. Now see, if charge capital Q is given to inner sphere, then charge minus Q will induce on the outer sphere to make its potential 0 as shown in diagram. Okay, this thing we have covered in my previous video, but okay, I'll just tell you. See here, let's take here, this is the inner sphere here. Okay, inner sphere students, how much charge is there? This inner sphere is having charge Q. Q charge is there. How much charge? Q charge is there. Okay, and let's take here, this one is having radius how much? This one, inner one is having radius R1, and let's take this outer one is having radius R2. Now this is inner sphere, radius R1, outer sphere, radius R2, and this outer sphere is R3. Okay, now what we are telling? We are telling that here how much charge will induce on the surface? Minus Q charge will come. That one we have covered in a previous video, but okay, still I will just show you here. Let's take here. Here I have taken potential A, and here I have taken potential B. Okay, I will just show you here. Okay, so see here, at point B, I am going to tell you how the charge minus Q will come. Okay, then we'll come to the capacitance formula. So students, you know very well here, at point B means potential. Potential at point B means potential at point B due to which one? Inner sphere, and due to outer sphere also. Okay, that means VB point B with respect to inner sphere is where? Point B. Okay, inner sphere I am writing here 1, VB1 and VB2. Two sphere is there na? Now students, tell me please here. Point B with respect to inner sphere is where? Outside. Where? Outside. Point B with respect to the inner sphere 1, outside. Similarly, point B with respect to 2 is where? On the surface. On the surface. Okay, now see. Outside means whenever the point is outside of the sphere, we have to always take the actual distance. That means what is the thing is there? K into Q by R1. R1 or R2 students? Outside na this distance R2. K into Q by R2 plus K. Let's take here how much charge is there? Here X charge is going to come. How much? X charge. So we'll write here K into X by R2. And here you know very well, as the outer one is connected to ground, that means potential how much here? Connected to ground means potential how much here? 0. So when you will solve this students, here X will come how much here? This X will come minus Q. Okay, just for you I have just proved here. Now how much charge will come? This X value will come how much students here? Minus will come. Okay, remember that. Now what I will do? I will rough all these things because now you have seen all this. Now because this we no need, but just for you I have just done it here. Okay, great. Now students, you know very well, here on the outer one, how much charge is there? X value, how much we have got? X value we have got minus Q. Where this value will come? This minus Q will come here. Okay, X value how much? This X value is students, this value is minus Q. Okay, here plus Q, here minus Q. Now student, after that, let's see here now. We got minus Q, now let's see here. Electric potential of the inner sphere is given by which sphere? Inner sphere. Now here, let's take here point A. So students, again, inner sphere means where? At point A now. Okay, at point A. Right here please, potential at point A, that means potential at point A due to first one, that means inner one, potential at point A due to outer one, that means 2. Okay, now see here please, this point 1, point A with respect to 1 is where? On the surface. S means what? Surface. After that, again you see, point A with respect to 2 is where? Inside. Again I am writing where? Inside. Okay, great. Now after that, see here, potential at point A is given here, K into, surface means, as it is, will write here, K into Q by, how much is there, students, here? By R1 plus K due to outer one, due to sphere number 2, how much charge is there on this? Minus Q. Okay, and point is where? Point is inside. Point A is inside of the outer sphere. That means which potential we have to take? We have to take the surface potential, because whatever potential at the surface of outer sphere, same potential will be inside. That means which distance we have to write here? We have to take the surface potential now. Again I am writing this is in means which one? Surface potential of 2. Okay, that means minus Q by R2. Okay, I hope so. This is very clear. That means, students, if you will simplify this here, we can take KQ common here. Okay, so we can write here, see, potential at point A means I have taken KQ common. It will become here 1 by R1 minus 1 by R2. Okay, we have written here the equation 1. We have got it. Now, capacitance of this capacitor is given by, okay, so capacitance C equal to, how much charge is there? Q charge. How much charge is there? Q charge. Now, because you know very well, the capacitance stores the energy where? In the electric field. So, even if I draw the electric field also, where will be electric field? Electric field will be here, in this region, like this here region. Start from the positive charge and at a negative charge. Like this here, electric field will be there. Now, in this electric field, what will happen? Energy will store, because capacitance, it is a device which stores charge and energy. So, energy will store in the electric field. How much? We know C equal to Q by V. What is V? V is the potential difference between the two plates. So, one plate is the inner plate. How much potential? A. Another one is the which one? Outer plate. How much potential? B. That means potential difference. VA minus VB in the direction of the electric field, potential decreases. That means what to write here? This is having charge how much? Q. Here potential A, here potential B. That means what to write? Q by VA minus VB. Okay, now see, Q, here potential VA, B how much? 0. That means how much coming? Q by VA. Okay, because anyhow, outer one is connected to ground. That means C equal to, how much, student? C. C equal to what we can write here? Again I am telling, see, between the plates, what is there? If in case air is there, so anyhow I will write here the C naught. Air is there. I am considering between the two concentric spheres, what is present? Air is there. Okay. So Q by VA value how much? Put from here. KQ 1 by R1 minus 1 by R2. Okay. What will happen? The students see, this Q and this Q will cancel out. So it will come here 1. Value of K how much? Value of K how much? Yes, 1 by 4 pi epsilon naught, and here 1 by R1 minus 1 by R2. Okay, 4 pi epsilon naught will go up. That means the capacitance will come how much? Sometimes they will ask directly in exam 1 by, not A actually, 1 by R1. No? Sometimes even they will ask inner radius is A, outer radius is B. That time you can write 1 by A minus 1 by E. Okay. So this is the capacitance of the spherical capacitor, when which one is connected to the ground? Outer sphere is connected to the ground. Okay. This is case number 2. Now students, see here please, third case. Now see here, capacitance of a concentric sphere when inner sphere is earthed. Which one is earthed? Inner sphere is earthed. Okay, that means here, this one here. Now I have connected to the ground. Okay, I'll just connect it to the earth here, like this here. Inner one is connected to the ground. And anyhow, we know very well, this radius I will take R1, and let's take this radius, outer radius I will take how much? R2. Now this one we know very well. Now see, if charge capital Q is given to outer sphere, previous one we have given inner sphere, now we are giving outer sphere, then charge minus Q R1 by R2. See here, minus Q R1 by R2 will induce on the inner sphere to make its potential 0 as shown in a diagram. Okay, so see here please, the charge we are giving to the which sphere now? Just a reverse situation is there compared to the previous one. Okay, so here we have given the charge, how much? We have given the charge Q on the outer sphere. That means how much charge will induced on the inner sphere? How much charge? Minus Q R1 by R2. Okay, so for that again in the previous video I have done it, but okay, anyhow I will write here. Let's take here potential how much? A. Okay, and let's take outer point potential how much? B. And let's take how much charge is going to induce? X charge is going to induce. Okay, we are going to find out the value of X, and this will come this one here. Okay, so see here, see at point A. Now at point A. So students here please, at point A means VA1 plus VA2. 1 means inner sphere, 2 means outer sphere. So see here please, 1. Now you think point A with respect to 1 is where? Point A with respect to 1 is where? On the surface. Where? On the surface. Similarly, point A with respect to 2 is where? Where? Inside. Inside. And inside means always which potential? Surface potential. Okay, great. Now students, if I write here, see, here I can write here, see, K on first sphere, that means VA1, how much charge is there? X charge is there. So K X by how much? R1 surface. K into X by R1 plus K, here how much charge is there? Q charge. Okay, and whatever potential at the surface, same inside. That means now which distance we have to take? We have to see the R2 distance. And as you know very well, point A is connected to ground. Point A is connected to ground. That means potential how much? 0. So when you will simplify this X value will come how much? This one. As I have told you, minus Q R1 by R2. Just for you, again I have did the derivation. Now we have got the charge X on the inner one. How much is there? How much is there? Which charge is there? Minus charge is there. Okay, so let me write here. This minus charge here. This minus charge. Okay. And please remember that here, this minus charge to make the electric field inside the conductor 0, maybe some charge on the inner surface, some charge on the outer surface. But okay, whenever we are seeing the potential due to the thin cell, we will just see how much charge on the cell. No need to worry about whether inside or the outside. Okay, so how much charge is there? Just let me write here the value minus Q, and here how much? R1 by R2. Correct? Minus Q R1 by R2. Now students, what I will do here? Just I will rough all this, no? Because already we have done it. No? This. No? Now again same story. What is the story here? See. Now electric potential of the outer sphere is given by electric potential of which sphere? Outer sphere. And outer sphere, what point I have taken? B. That means students here please, at point B. No? At point B. Right here please. VB equal to VB1 plus VB2. Now think, again you think. Point B with respect to 1 is where? Outside. Point B with respect to 1 is where? Outside. Similarly, point B with respect to 2 is where? On the surface. Okay, great. Now let's see here. This potential VB. No? This potential VB. We have to put the values very well. K. Now 1 means here please, 1 means how much charge is there? Think, see here, minus Q R1 by R2 charge is there. Now here, see here. Now point B with respect to 1. See, 1 is there now, that means we have to see the charge on the first one here, minus Q R1 by R2. And which distance? Outside this, that means which distance? Actual distance we have to take, that means by R2. Plus, now again K. Now point B with respect to 2, on the 2 how much charge is there? Q charge is there. And anyhow surface 1, that means what to write here? Here again we have to write here R2. Okay, so this thing we have got here. And what are the things we can take common here? You can see here KQ by R2 we can take common. See, I will write here, see. Here itself I will write here VB. What is there? KQ by R2 I have taken common outside. That means what this will come? 1 minus R1 by R2. See, very well. VB. KQ by R2, 1 minus R1 by R2. Okay. This I will write here. This one, see. potential at point B, that means outer one what is there, KQ by R2, and here 1 minus R1 by R2. Okay, even if you will take the LCM also, see KQ by R2, and here how much coming here, R2 minus R1 by R2. Okay, good. Now students, see capacitance of this capacitor is given by, again, C naught equal to how much charge we have given, Q on the outer one. Okay, and how much potential difference now? Before that the potential difference was VA minus VB, previous situation, case 2. But now here, see, here B and here how much? A, because electric field in which direction? If I talk about here the electric field, students, see, electric field now it will be like this here. Now see, from positive charge to negative charge, now what will happen? It will store the energy in this. Like this electric field will be there. And this time we'll write VB minus VA. What we are going to write, students, here, see, VB minus VA. Now what is there? Inner one is grounded. VA is 0, that means Q by VB. Okay, let's put the value Q, and here VB value how much here, see, KQ. Here we can write here, see, R2 minus R1 by R2 square. Okay, and what other things will cancel out? Anyhow, this charge Q and this charge Q will cancel out. That means, students, we can write here C naught is equal to K value how much here? 1 by 4 pi epsilon naught here, please, I'll write here 1 here, 1 by 4 pi epsilon naught into, see here, R2 minus R1 by R2 square. Okay, that means what will happen? This capacitance will come here, see, 4 pi epsilon naught here, see, R2 square by R2 minus R1. See here, correct? Huh? Is it? Huh. So students, this thing we can write even in a one more form is there, see, even we can write like this also, see, 4 pi epsilon naught here, R1 R2 by R2 minus R1. Later when you will simplify this, na, you can get it like this also, 4 pi epsilon naught into R2, because this case will be similar to the case number 2 and this one will be similar to the case number 1. So case number 3, here the addition of case number 2 and case number 1 is there. Okay, and sometimes question used to come. What question used to come? They will ask the difference of the capacitance between the third case and the second case. So see here, please, C naught third case minus C naught second case. C naught third case how much here? This one we know very well, is it? Let me write here, 4 pi epsilon naught. What is this? R1 R2 by R2 minus R1, na, plus 4 pi epsilon naught R2. After that, see, second case. In second case, when you will write here, it will be like this here, 4 pi epsilon naught R1 R2 by R2 minus R1. What other things will cancel out? If you will see here, students, see, this thing and this thing cancel out here. We are taking the capacitance of third case and second case. That means anyhow, what answer will come? This answer will come. Okay, this answer will come. So students, I hope so, students, na, just see it very well. So I hope so, this spherical capacitors 3 cases is very clear to you. Okay students, keep studying, keep going.